Good day to you. This is teacher Leland Alejandro, and we're going to discuss today special segments in the circle or special segment measures in a circle. This will be involving problems like intersecting of two chords, intersection of two chords, also intersecting secant and a tangent at the exterior of the circle, also two secants intersecting at the exterior of the circle. So these are belong to three types of problems. All right, so this will be involving two chords or one secant and one tangent or two chords. Okay. All right, so we shall see the examples in the worksheet. All right, so let us see the worksheet for this special segments. Okay, let us make use of the whole page first. All right, this is the special segment measures lecture examples, and this will be involving the circle and a combination of segments, okay, which will be either tangent, secants, or chords. All right, so let us start with the first problem using the presentation view. Okay, so here is solve for x. Assume the lines which appear tangent are tangent. Now, as you can see in the diagram, we have a circle, we have a secant. Okay, a secant is a segment which intersects the circle at 2 points. Okay, there. All right. Now, a tangent intersects the circle at 1 point. Okay, there. So we call this point a point of tangency. Now let us discuss a little bit of the concept about intersecting secant and a tangent at the exterior of the circle. So let us draw first the diagram. We will start with a circle. Let me draw a circle and a secant. Okay, secant is this particular line segment intersecting the circle at 2 points this way. Okay, whereas a tangent intersect the circle at just 1 point like this. There. Okay. Now let us put labels. Let's call this point say A, and this intersecting of circle, and the second point B, and this other intersection we will call it point C, and then the point of tangency, okay, the intersection of the tangent and the circle, we will just call it point E there. Okay. All right. So point E is the intersection of the tangent and the circle. Now the points B and C are the intersection points of the secant with the circle. Now the theorem about this secant and tangent combination is the product of the length of the secant and its external segment is equal to the square of the length of the tangent. Okay, so first we will define first the segments. Okay, so for the length AC, this is the length of the secant. Okay, so this is actually length of the secant. There, the length AC. Now the AB, the length AB, this is the length of the external segment of the secant. Okay, length of the external segment of the secant. There. Okay. Now AE, the length AE, this is the length of the tangent. Length of the tangent. There. So these are the corresponding lengths of the segments. Now the theorem is something like this. The theorem goes like this. The product of the length of the secant and its external segment okay, is equal to the square, equal to the square of the length of the tangent. Yeah. So in a formula, it will be AC. Okay, the formula. All right, the formula is AC. Let's use capital letters. AC times, all right, that's AC times AB, all right, is equal to AE squared. AE, and then we put a 2 over here, squared. All right, there. Okay, so this is the formula. AC, the entire length of the secant, times its external segment or exterior segment AB is equal to the square of the length of the tangent AE. So that's AC times AB is equal to AE squared. Okay. All right. So this will be our working formula. All right. All right. So much for the concept. Let us solve the problem. All right. Let me clear the screen. Okay. Let me clear the screen. So in our working equation, it will be something like this. Since there are no labels for the points, okay, there are no labels for the points, we will just use the assigned lengths. All right, the length of the secant is the sum of the x and 8. So x plus 8, that's the entire length, okay? That's the entire length, this x plus 8. This is the entire length of the secant. Now, multiply this by the external segment of the secant. This will be 8. 8 times x plus 8 there. And this is equal to the square of the length of the tangent, which is 12. Okay, so this is equal to 12 squared. Okay, well, we'll put a number 2 there. All right, there. Okay, okay, so this is our formula. This is our working equation. So the entire length of the secant is x plus 8. Multiply this by the external segment 8, the outside segment over here. Okay, we're talking about this length here, there. Okay, so it's x plus 8, the entire length of the secant, multiplied by that exterior length 8. Okay, which is equal to the length of the tangent 12 squared. Okay, so that means 12 times 12. Okay, so if we solve this, this is going to be like 8 times x plus 8 is equal to 12 times 12. Okay, like this. And so we will continue by dividing both sides. We will divide this by 8. Okay, we will divide this by 8. And we will also divide this by 8 like this. Okay, and so we put a division there. So this will be divided by 8 like that. Okay, and so this 8 cancels out with the 8. And the left side will only be x plus 8. See, this is x plus 8 like this. And this equates to how much is that? We have 3 here, and if we will take a 4 in the 12 and we will take a 2 in the other 12, so we will be having a remainder of 3 and 6. So we will still have here 18 there. Okay, all right, how did I do that? This is something like the 12 times 12. These are factorables to 4 times 3 and 2 times 6. Okay, this is 12 and this is 12. Okay, 4 times 3 is 12, 2 times 6 is 12. Okay, and so this is to be divided by 8, which is 4 times 2, like that. So the 4 divides by the 4, the 2 divides by the 4. The only remaining numbers are 3 and 6. So 3 and 6 is 18. Okay, so that's how I got the 18. So it's a shortcut in division. Okay, getting the factors and then cancel. All right, so you have 3 and 6, that's 18. We continue with our solution. We subtract 8 here, and we subtract 8 there. All right, and so the remaining expression should be x equals 10. And so we already have our answer. Okay, since this is solved for x, we already found the value of x, and must be 10 units there. Okay, this is our answer. All right, so let us check and verify what's the value of x. Try to see the answer below the diagram or beside the diagram there. Okay, all right, so here you can see the answer from the computer. It's 10. The length of x is 10. All right, so that goes to our first number. Let's continue with the next. Let us clear the screen and proceed to number 2. Okay, here's number 2. Solve for x. Assume the lines which appear tangent are tangent. Okay, we can see from our diagram, this is a tangent here. This is a tangent, okay? Intersecting the circle at one point. This other length is a secant, this one, okay? That's a secant there, okay? Let me do it correctly with another color, okay? So let us make use of, say, blue. Can we use blue there? Can we use a blue there? Okay, let me try a blue color. Okay, that's the secant length. Okay, so our theorem here. Okay, the product of the length of the secant. Okay, the product of the length of the secant and its external segment is equal to the square of the length of the tangent. Okay, so our working equation here, since the product of the length of the secant, what is the length of the secant? The length of the secant will be x plus 12. There, that's the length of the entire secant. The blue segment, that's the entire length. Now, we will multiply this by the external segment of the secant, which is the 12. So we put a 12 here, there, okay? 12 times the expression in the parentheses. All right, this is now equal to the square of the 18, okay? That's the length of the tangent. So this is 18 squared, okay? So put number 2 right there, okay? 18 squared. Okay, so again, we will continue by dividing this equation by 12, okay? So we have here 12 times x plus 12 is equal to 18 squared is 18 times 18 there, and this is to be divided by 12, and this is to be divided by 12, and then this is division, okay? This is divide. Let's change this back to red. Okay, let's go back to our red. Okay, this red already. Red. Let me check that. This red already. Red. Okay, there. All right. So we divide this, and this cancels out. The 12 and the 12 cancels out. All right. Now again, we can simplify our division here. We have here 18 times 18 means 6. 6 times 3 is 18. Okay, times the other 18, which is 2 times 9. Okay, there. Okay, 6 times 3 is 18. 2 times 9 is 18 divided by 12, which is 6 times 2. That's also 12. And you can see the numbers. Okay, you can cancel that out, and the only remaining numbers are 3 and 9. That means 27. Okay, so we continue here with the 27. X plus 12 is equal to 27 there, and here's our working equation. and this simplifies to x plus 12 equals 27. So we will do subtraction now, minus 12 and minus 12 there. And next line will be x equals 27 minus 12. That will only be 15. And that's it. Okay, that's the x. Okay, we're asked to find the x, and so this is our answer. Okay, we can now verify from the computer's database. Okay, you can see the answer below the diagram. Okay, there. Okay, all right, I'll make it blink. Okay, there, it's 15. All right, there. So that confirms our answer. Okay, that's correct. The length of the x. Okay, so just remember for this type of diagram, okay, if a tangent and a secant of a circle intersects at the exterior of the circle, then the product of the length of the secant and its exterior or external segment is equal to the square of the length of the tangent. Okay, all right, so that will be for this type of problem. All right, let's continue with number 3. Let me clear the screen and proceed to the third number. Okay, we have the same diagram. Okay, we have the same diagram. Again, we have a tangent over here colored red, and then we have the secant FH over here, there, colored blue. Okay, and we're asked to find the length of the blue segment. Okay, find FH. All right, so we'll still be using this theorem, okay, which is in the memory. Okay, there. All right, the product of the length of the secant and its external segment is equal to the square of the length of the tangent. Okay, which we actually used in the first number. All right, so the same formula that we can use. So we can now have FH. Here's our working equation. All right, the external segment of the secant is FG. Okay, let's use capital letters, FG. All right, multiply this by the length FH. There. All right, it says the product of the length of the secant and its external. So it's FG times FH, which is equal to EF squared. Okay, EF squared. Okay, there. Okay, all right. So using the expressions given, we have FG at a value 18. There. And then this is to be multiplied by FH. So FH, what is the length of H? What is the length of FH? It's 9x plus 5 plus the 18. There. All right, because 9x plus 5 is the length assigned to HG. Okay, HG. All right. Now, FH is HG plus FG. Okay, all right. So when we express FH, it will be 9x plus 5 plus 18. And that's the entire length. And this is equal to the square of EF. That means 30 squared. So this is 30 squared. Here's our working equation with dx. And so we will have to solve for x first. Okay, solve for the x first, and then afterwards we can now use it in the FH. All right, and so we shall simplify our solution here. All right, so we start with 18 times 9x, and this is plus, that will be 5 plus 18, that will be 23. And this is equal to 30 squared is 30 times 30, like this. And we shall divide this by 18. Okay, divide this by 18 and divide this by 18. Okay, and we put a division symbol. All right, so this is divide. Let's use again, let's go back to our red Okay, this is supposed to be red, and this is divide. Okay, and divide. All right, we shall simplify the division there. All right, we can have factors of 18, factors of 30 and 30, and so we can continue like this. 30 is 6 times 5. That's a 30. The other 30, we can use their 3 times 10, like that. Okay, 3 times 10. There. Okay. All right. So 6 times 5 is 30. 3 times 10 is also 30. Now 18 is 6 times 3. There. And so we cancel out the 6, we cancel out the 3. We have 5 and 10, that means 50. There, okay? And so this cancels out. And so we know 30 times 30 divided by 18, that's 50. So we will continue with our next line, like 9x plus 23 is equal to 50. There, okay? And so our next step is to subtract the 23 from both sides. There. And so the left side remains 9x, and the right side is now just, how much is that? 10 and 3, 7, 4 and 2. That's 27. Okay, there. Okay, of which we will continue by division, which is to divide 9x by 9. And 27 by 9. So this is by 9 and by 9 there. And this is divide, okay? So this is division, and division x looks like 3, okay? And so we found our x is equal to 3, and we will not stop there. We're after the length fh, okay? FH. So solving for FH, we shall do it over here. All right. So FH is equivalent to what expression? FH is 9x plus 5 plus the 18, okay, which is actually equal to 9x plus 23 there. And so we will make use of the x now. This is 9 times x is 9 times 3 plus the 23. And this simplifies to 27 plus 23, which will give us how much? This is 10. That looks like 50. And so FH is 50 units. Yeah, okay. This will be our answer. Okay, this is our answer there. 50. All right, that's FH. Okay, we're asked to get FH. Find the measure of the line segment FH. All right, so let's check and verify from the computer. Look at the diagram, and below the diagram will be the answer. There. Okay. All right. So there. Confirmed by the computer, our computation is correct at 50 units. All right, so that goes to our third. Let's continue with number 4. Let me clear the screen. Here is number 4. The same figure, one tangent, one secant, intersecting at the exterior of the circle. All right, so we will still follow and copy and paste. In our, from the first number, that's where we started typing this, so it's still in the memory. I will just paste it here. All right, the product still in the clipboard. So the product of the length of the secant and its external segment is equal to the square of the length of the tangent. So our working equation here will be, all right, the length of the external is FE. Okay, so here's our solution. All right, our solution will be FE times FE times GE, yes, like that, Okay, it's external is FE, the entire length is GE. The secant is equal to DE squared. Okay, DE squared. All right, so we put the number 2 on top. Okay, that means squared. DE times DE. All right, so let's put the equivalence of FE. FE is 12, the external length of the secant, multiplied by the entire length GE, which is 2x plus 1 plus 12. Okay, there, that's the entire length, is equal to DE, which is a number 18 squared. Okay, so this will be, of course, squared. All right, like that. Okay. Okay, so let's simplify our working equation. This will become 12 times 2x plus 13 is equal to 18 times 18. There. Okay, and let's find out if we can simplify this. So this will become 12 times 2x plus 13, and this is 18 times 18 divided by 12. Okay, so we will be dividing this by 12 and the right side also by 12, and then we put a divide symbol there. Okay, just a line. All right, this is divide and this is divide. All right, so again, the factors of 18 and 18 contains the factors of 12, so we can do it this way. 18 is factorable to 6 times 3. The first 18 is 6 times 3. The other 18 is 2 times 9. There, okay? So we can use these numbers, all right? 6 times 3 is 18. 2 times 9 is the other 18. The divisor 12 is 6 times 2. These are the factors of 12. And we can simplify now. 6 and 6 cancels out, 2 and 2 cancels out. Remaining numbers are 3 and 9, which provides us 27. Okay, so we know the right side of the equation is just 27. All right, and so this cancels out. And we have 2x plus 13. This is now 2x plus 13 is equal to 27. Yes, okay. We continue by subtraction property, minus 13 and minus 13. All right, we have 2x equal to 27 minus 13, which looks like 14. Yes, all right. And we continue at the right side space. We continue over here, all right. So this will be 2x equals 14. We will be using division property. So 2x is equal to 14. We divide by the number 2. Yeah. Okay, so this is now divide. Put division symbol there. This is divide, and this is also divide. X equals 7. Okay. All right. So we found our x, but we will not stop there because we're asked to get not just the x, we're after FG. All right, FG. Okay, solving now for FG, we will do it over here. I hope it fits in this particular space. We will have our FG. FG is equal to the expression 2x plus 1. You can see from the diagram. And we can now use the value of x that we have, which is 14. I mean 7. All right, so x equals 7 is, the value of x is 7, so we can use it here. 2 times 7 plus 1. There. All right, so it looks like we have the final answer. 14 plus 1 is 15. So this is 14 plus 1. FG is 15. Okay. All right. So we'll pull it. We will write it over here. So let's put it over here. FG is 15. There. Okay. That's our final answer. Okay. This is our final answer over here. FG is 15 units. Let us check and verify. Below the diagram, we shall find the answer. There. Okay. Okay. I'll make it blink. All right, so that's over there. It's 15. All right, so we're correct. Let's continue with number 5. Clear the screen and continue with the 5th question. All right, here's the next. All right, we have a different type of problem here. We have intersecting chords. Okay, a chord is a segment whose endpoints are on the circle. Okay, whose endpoints are on the circle. So let us discuss first the concept about this. All right, so we have a circle. All right, this is a circle. Let's make it larger and let us put, all right, let's put one chord. Okay, here's one chord and another, say we put over here. All right, there. So we have 2 chords here. Let's make my other chord perfectly intersecting. Let's put it there. Okay, there. And then we put some labels so we can describe the formula. Let's put here A. Let's put here B. And let's put here C. And let's put here D. There. All right. The intersection of these chords, let's just mark it, say O. Yes, there. O. All right. The theorem here is, all right, the product of the segments of a chord is equal to the product of the segments of the other chord. Okay. All right. So if we're going to write the theorem, the theorem for this type of intersecting chords of a circle, okay, is something like this. The product of the segments of a chord is equal to the product of the segments of the other chord. There. Okay. The product of the segments of a chord is equal to the product of the segments of the other chord. All right. So let's put this in the clipboard. So we will use it each time we encounter this diagram. Okay. There. All right. So we'll just paste it in each time we solve another problem like this. Okay. All right. Okay. So the theorem, the product of the segments of a chord is equal to the product of the segments of the other chord. All right. So if we choose the chord AB, okay, then we have AO times BO. Okay. So it's something like this. All right. AO times BO. Okay. That will be the segments of chord AB. And that's equal to the product of CO times DO there, which is actually the product of the other chord, the product of the segments of the other chord. Okay. All right. So if we're going to explain this, it goes like this. Okay. It goes like this. So it's let me change the color. Say green. All right. So it will be like this. This length AO. Okay, let's change this to green. All right, I hope I was able to get the color. All right, so this segment, okay, AO, all right, times BO. Let's use another color, okay, times BO, okay. So it's the green length times the yellow length, okay, and that will be equal to CO, okay. That will be equal to CO. Let me use another color, say black. All right, so that's equal to this length, okay, times the other part of that segment, DO, okay, it's this segment here. Okay, all right, there. Okay, so visually, looking at the colors, okay, the segment green times the segment yellow is equal to the product of the segment that is black times the segment that is blue. Okay, like that. So easy to remember. Okay, all right. So this will be our concept, and this will be our theorem each time we encounter this diagram. Yes. All right. So solve for x, assume that lines which appear tangent are tangent. So for number 5, we're after the length with the x there in the diagram. All right, so since there are no letters there, we will just use the numbers for our formula. And so let me clear the screen. Okay, let us continue with our solution. This will now be for the segment containing the length 10 and the length 4. So that means 4 times 10. 4 times 10 is equal to 5 times x. Okay, 5 times x, or simply 5x there. Okay, let's go back to our usual red. All right, so 4 times 10 is equal to 5 times x. Okay, remember what we discussed, and this is now going to be 40 equals 5x, which continues with division property. We divide by 5, like that. Okay, our divisor will always be the coefficient of the letter. Okay, all right, let me change back to red. Okay, there. All right, so this will now be division, and we have x equal to 8. Okay, x is equal to 40 over 5 is 8 there. So this will be 8 units, unit of length, of course. And that's it. This is our answer. Okay, x is equal to 8. All right, 4 times 10 is equal to 5 times x. And let us see the answer there. Okay, you can see it below the diagram. Okay, the answer is 8 there. Okay, so that goes to our number 5. Let's continue with number 6. All right, let me continue with the next diagram. Solve for x. So we're solving for this length, okay? The length over here. I will mark it red there. How long is that segment? Okay, if you still remember what we discussed in the previous problem, then our working equation will be the length 9 times dx, the length 9 times dx, or simply 9x, must be equal to the product of the segments 6 and 6. So this is 6 times 6 there. Okay, all right. So we have something like 9x is equal to 36. Okay, then we divide by 9 and divide by 9. Okay, there. And so 36 divided by 9 is 4. So our answer must be 4 units. So this is 4 units there. And this is our answer. Okay, and check the answer. Watch it below the diagram. There, okay? You can see it below the diagram there. And so that goes to our number 6. Okay, intersecting chords inside a circle. All right, let's continue with number 7. Here's number 7. All right, here's number 7. Find the measure the line segment indicated. Assume the lines which appear tangent are tangent. Find DF. All right, we're looking for which segment length. It will be this one. There, we're looking for the length DF. I marked it red. All right, so the same principle that we used a while ago. This time we have labels for the points. So we can work it out our working equation. So for our solution, it goes like this. We have CV times VE must be equal to FV times VD. There, okay? All right. Now we will make use of the equivalents of these segments. CV happens to be 16. And this will be multiplied by the other segment, 21. And this is equal to the product of FV, which is 2x plus 10. So this is 2x plus 10. There. Multiplied by the remaining part, 14. There. Okay. So this will be our working equation. Okay. All right. So to continue, we're going to divide this by, the 14. Let's divide this by the 14. There, okay? And we will put a divide symbol there. And this cancels out. So this cancels out with the other 14. And let's see the factors of 16, 21, and 14 of the left side. Okay, so 16 is something like 2 times 8. Okay, 2 times 8 or 8 times 2. There, that will be the factors of 16. 8 times 2 is 16. 21 is 7 times 3. So this will be 7 times 3. This is how I do my simplified division. Okay, there. So that takes care of the 16 and 21. How about the divisor 14? The divisor 14 is 2 times 7. There. And so you can see the numbers, the 2 cancels out and the 7 cancels out. Remaining numbers are 8 and 3, which means 24. Okay, there. And so the left side of the equation now will just be 24. Okay, so this will continue with 24 is equal to 2x plus 10. There. And so we subtract 10 now. We'll continue by way of subtracting 10. Subtract 10 from the left side, subtract 10 from the right side. And so the left side continues with 14. Okay, 4 minus 0, 2 minus 1, that's 14. The right side is just 2x. Okay, the 10 and the negative 10 gives 0. Okay, so this is our latest simplified equation. 14 equals 2x. We continue by divide. Okay, so this will be division by the 2. Okay, so this will just be divide by 2. And so x is equal to 7. Okay, x is equal to 7. There. And so we found the x, but we're not after the x. We're after df. Okay, and so df, we shall solve it over here. Let's put it here. All right, this will now be for df. Okay, so solve df. Solve df. All right, so df is equal to 2x plus 10 plus 14. 2x plus 10 plus the 14. Okay, we can now use our x. So this is df is equal to 2 times x, which is 2 times 7, plus 10 plus 14 is 24. Yes, 24. So we have 14 plus the 24. There. So this looks like 38. Yes. Final answer is 38 units. There. Okay. So that will be our answer. 38 units. Okay. That goes to our DF. All right. Let's check and verify from the diagram. Yes, you can see it below the circle. Okay, it's 38 there. Okay, all right, so this means correct. Let's continue with number 8. All right, let's continue with number 8. Clear the screen. Number 8 now. All right, here's number 8. The same diagram, two intersecting chords inside a circle. So our working equation will still be using the theorem. Product of the segments of a chord is equal to the product of the segments of the other chord. All right, and so our working equation will be KW times WM. Okay, WM must be equal to LW times WN. Yes, WN. All right, so this is our work equation. But we're after MK. All right, where is MK? Okay, let's put a mark there. Okay, let's mark it. MK is from M to K. There, I marked it red. All right, so what is the length of the red segment? Okay, MK. So here's our work equation. Segment KW times segment WM is equal to segment LW times segment WN. So our equation will be KW, that will be expressed 2x minus 4. So this is 2x minus 4 times 15. Okay, must be equal to LW, that's 10, times the segment WN, which is 24. Okay, there. Okay, all right, so we have a simple linear equation here. All right, a simple linear equation here, and we shall continue by division. We can write it this way: 15 times 2x minus 4 is equal to 10 times 24. Continue by division by 15, like this, and then we put a divide. All right, so we put a divide here, and we put a divide there. All right, and so we can simplify our division. 10 is how much? 2 times 5? That's 10. 2 times 5. 24 is 3 times 8. There. Okay, 3 times 8 is 24. So this means 10 times 24. There, expressed using the factors. All right, 15 is 5 times 3. That's 15, the divisor 15. And so we just cancel out the factors there. Remaining numbers are 2 and 8, which means 16. Okay, so the right side of the equation is just 16. Okay, and this cancels out also. This cancels out, the 15 and the 15. And so our left side is 2x minus 4 equal to 16. Yes, like that. Okay, so we continue by a way of addition property. We add 4 to both sides of the equation there. And so left side becomes 2x, right side is 20 there. And so we continue by divide. So we will divide by 2, divide this by 2, and divide this by 2. And then we put a divide there. We put a divide, and x has a value 10. Okay, so our x is 10. Okay, and so we can now solve for the requirement. Let's go back to MK. All right, we'll do it over here. Okay, so what is segment MK? So we write here solve for MK. Use capital letters, MK. All right. Now MK is equal to the expression 2x minus 4, 2x minus 4 plus 15. There, okay? We're adding the lengths kw and wm, okay? Because that's the entire length mk. All right, and so we shall use the value of x. So we now have mk is equal to 2 times x is 2 times 10 minus 4 plus 15. There. All right, so we have, how much is that? We will have mk is equal to 20. That's 20 minus 4 plus 15. That looks like 16 and 15 is 31. So mk is equivalent to 31 units. There, okay? All right, that's our final answer. Our final answer is 31. Okay, there. Let's check and verify from our computer. Yes, it's below the diagram. All right, you can see the answer, 31 over here. There, all right, so this is correct. We continue with the next number. Do we still have another one? Let's continue with number 9. Or is this the last number? We still have the next. All right. This time we have 2 intersecting secants at the exterior of the circle, okay, at the exterior. So this is a different type of diagram. The first one is a tangent and a secant. The second are 2 chords inside the circle. This is the third combination of 2 secants, okay? And so the theorem here is, it's quite different, but we shall start with a drawing. Okay, we shall start with a drawing. So we draw a circle first. So let us draw a circle, and then we put a secant. Let's follow the example. We have a secant, and then we have another secant. Okay, remember a secant intersects the circle at 2 different points. Okay, all right. So we have 1, 2, 3, 4. We have 5 points here. Okay, 5 points. Let's call this A. Let's call this B. Let's call this C. Let's call this D. And let's call the exterior intersection, let's just call it O. Yes. All right, there. Okay. Okay, the theorem here is something like this. The product of the secant, the entire length of the secant, and its exterior or external segment is equal to the product of the other secant and its external segment. Okay. Yes. All right. So it goes like this. This is the theorem. If two secants intersect, okay, if 2 secants intersect at the exterior of a circle, okay, let's put that because it's very long. Okay, if two secants intersect at the exterior of the circle, then, okay, all right, the product of the length of the secant and its external segment is equal to the product of the other secant, okay, other secant, and its external segment. There, okay. All right. Let's put this in the clipboard. All right, there. So each time we need it, we can paste it. All right, there. Okay. So if two secants intersect at the exterior of the circle, outside the circle, yes, then the product of the length, okay, there must be a G here, okay, there must be a G, okay, there must be a G there. All right, product of the length of the secant, and let me rewrite it. Yes, I want it correct spelling. All right, okay, this will be like if two secants intersect at the exterior of the circle, then the product of the length of the secant, okay, the product of the length of the secant and, okay, if two seconds intersect at the exterior of the circle, then the product of the length, this is supposed to be length, okay, the product of the length of the secant and its external segment is equal to the product of the other secant and its external segment. There, okay, is equal to the product of the other secant and its external segment. Yes, if two seconds intersect at the exterior of the circle, then the product of the length of the secant and its external segment is equal to the product of the other secant and its external segment. All right. In symbols, this will be something like this. AO, using the diagram, we have AO, that's the entire length of the secant, times BO is equal to CO times DO. Okay, there. Okay, so this will be in terms of the segments in our diagram. So the entire length AO times BO is equal to CO times DO. Okay, like that. All right. So if two seconds intersect at the exterior of the circle, then the product of the length of the secant and its external segment is equal to the product of the other secant and its external segment. All right. Okay, so this will be our concept for this diagram. Let's solve the problem. Let me clear my explanation. Let's do the next one. All right, so this will be our solution. Okay, here's our working equation. It will be, let's consider the first secant, the one with x and 9. So the entire length is x plus 9. Okay, the entire length is x plus 9. Okay, the external segment of that is the 9. So we will have to multiply this by 9, like that. And this equates to the other length, which is 17 plus 10. Okay, that's 17 plus 10. Okay, that's the length of the other secant. Multiply this by its external segment, measuring 10 units. There. Okay, so this is our working equation. Okay, all right. Remember the theorem. If two seconds intersect at the exterior, then the length of 1 secant multiplied by its external is equal to the product of the length of the other secant multiplied by its corresponding external segment. And this is it. 9 plus x is the entire length times the 9 is equal to the product of the other secant, 17 plus 10, times the 10, the external part of that secant. All right, so here's our working equation. Okay, all right, so this will be, how much is that? 27. We shall simplify first. 9 times x plus 9 is equal to 10 times 17 plus 10 is 27. There. And this looks divisible by 9. So we divide both sides by 9. There. Okay. All right. So we put a divide symbol there. And so the 9 cancels out with the 9. And we have the left side just x plus 9, which equates to 27 cancels out with the 9. 27 divided by 9, that's 3. So we have 10 times 3. Okay, 10 times 3, like that. Okay, remember the 27 cancels out with the 9, which results to 3. 27 by 9 is 3. So this will continue with x plus 9. X plus 9 is equal to 30. We continue by way of subtracting 9 from both sides. And x is 21. Yes. Our final answer must be 21. Okay, that's it. All right, there. And so what is the answer from the computer? Yes, it's 21. There. All right. Let's continue with the next number 10. Let's continue with number 10. All right, here's number 10. All right, here's number 10. Solve for x. Assume the lines which appear tangent are tangent. All right, there are no tangents in this diagram. They are both secants. All right, so we will still use the same principle. Okay, all right. The entire length of 1 secant is 15 plus 9. So this is 15 plus 9. That's the entire length of the first secant. Multiply this by its corresponding external segment 9. There. Okay. And this equates to, this is equal to the other length x plus 8. There. Multiplied by its corresponding external, that's the 8. There. Okay. And so this is our working equation. Okay, so, all right, so that's 15 plus 9, yes, times the 9 is equal to x plus 8 times the 8. All right, let's simplify. Let's start with the numbers. We have 9 times 15 plus 9 is 24, yes. So that's 24. This is equal to 8 times the same x plus 8. There. All right, this is now divisible by 8. Okay, so we have 9 times 24 is equal to 8 times x plus 8. All right, we divide by 8. Okay, we divide by the 8 there. So we put the divide symbol and the divide symbol over there. All right, 8 cancels out to the 8. And we have something like this. This is 9 and 24 is 8 times 3. That's 24. Okay, so that takes care of 9 times 24. 9 times 8 times 3, which is going to be divided by 8. All right, and so the left side is just 9 times 3, which is 27. So the left side is 27, and this equates to x plus 8. There. Okay. Remember, this cancels out also this. And so we continue by way of subtraction. So we do now 27 is equal to x plus 8. We subtract 8 from both sides, minus 8, minus 8. And so 27 minus 8 is 19. Right side is just x, or we usually write it x equals 19. So that's it. Our answer is 19. Okay, that's our final answer. Let's check and verify from the computer. Yes, it's 19. There. So this is correct, and that goes to our number 10. Let's proceed to number 11. Let me clear the screen. Number 11 now. Okay, here's number 11. Find the segment TV. All right. So where is this segment TV? So it must be this. I'm going to mark it with a different color. All right, there. So we're looking for that length. Okay, let's write our working equation. Our working equation will be the entire length of the secant TV multiplied by its external UV must be equal to the other secant JV times its corresponding external WV. There. Okay, here's our working equation. Let's use the expressions. TV is x plus 11 plus 7. Okay, so this is x plus 11, x plus 11 plus the 7. There. This is one quantity. Okay, the entire length TV is x plus 11 plus 7. Multiply this by the external segment 7. Okay, and this is equal to, all right, that's let's put the 7 after the group, okay, because that part is UV. Okay, so let's put the 7 here times the 7, and this is equal to JV. All right, our JV is the entire length, 15 plus 6. There, multiplied by WV. Our WV is the 6. There, okay, all right. Okay, simplification now. So x plus, that's 18 times 7, okay, which is equal to, how much is that? 21, okay, times the 6. There. All right, so anything we can simplify here? Can we divide by the 7? We can divide by the 7, okay, so this is x plus 18 times the 7 equals, let's break the 21. 21 is 7 times 3, okay? 7 times 3, that's 21, times the 6. And so we will divide now by the 7 and divide also by the 7. We can now reduce the numbers, okay? We'll be able to reduce the numbers. So we will divide by 7, okay? So this 7 cancels out. Also this 7. All right, so the left side will just become x plus 18. And this equates to 3 times 6 is also 18. Okay, and so it looks like our x is just 0. Subtract 18 from both sides. X is just 0. There. Our x is 0. We will not stop there. We're about to compute for segment TV. All right, we will do it over here. All right. So this will now be solved for TV. Okay. Now TV is equal to x plus 11, x plus 11 plus the 7. Also, TV is equal to x plus 18. Okay, And so this TV is equal to 0 plus 18. Final answer is 18. So TV is 18 units. There. That's it. That's our final answer. Okay, we shall check and verify from the computer. Check the answer below the diagram. There, okay? It's 18. And so this must be the right length of the segment TV. All right, let's continue with the next number. Let me clear the solution. Clear the answer. Number 12. Okay, here's another diagram with two secants intersecting at the exterior. All right, and so we will follow the same theorem. If two secants intersect at the exterior, then the product of the secant and its external segment is equal to the product of the other secant and its corresponding external segment. All right, and so our working equation here will be FD, okay, FD times ED must be equal to DL times DC. There, okay? All right, exactly what we explained a while ago. All right, let's write the expressions for FD. FD is x minus 4 plus 3. X minus 4 plus 3 times 3, okay? Times 3. That's equal to DL, that's 4 plus 2 times the 4, okay? Times the 4. All right, so we shall simplify first. Okay, what do we have here? X minus 4 plus 3 becomes x minus 1. So this will become x minus 1 times the 3. The right side will be 6 times the 4. Like that. Okay, and so this will become x minus 1 times 3 equals 24. Okay, then we shall divide by the 3 and divide this by the 3. All right, so we put a divide symbol there. Right side becomes 8. So left side becomes x minus 1. X minus 1 is 8. We continue by way of addition property, add 1 to both sides. And x is 9, okay? There, okay? All right, we found our x, but we're after FE, okay? All right, solve for FE. So this will now be solved for FE, okay. All right, so what's FE equal to? FE is just x minus 4. So this is x minus 4. All right, our FE is equal to 9, the equivalent of x minus the 4. FE is 5 units. Okay, all right. That's our computed value. Let's see the answer. All right, so what we have is 5. Is it really 5? Check. Yes, okay, you can see it below the diagram there. The red number 5 there. Okay, that means this is correct, all right. Okay, so let's continue with the next number. Do we still have number 13? Then we clear the screen and... Okay, that looks like the last number. All right, so that'll be it. And we'll continue with other topics later and see you later. This will be for now. All right.